Dear students, here is an database systems. What is a fundamental database systems? I am taking History and Navet, the 7th edition. From that, I am going to uh, define data models and their categories, schemas, instance and states, three-schema architecture, data independence, DBMS language interfaces. These topics I am going to take in this section. Now, data models. What is data model? So everyone to understand data model. So we are going to design this database based on the user requirements. So before designing this database structure for user requirements, we have to know what are the data models and how data models to be constructed. Here definition you have to know. Data models a set of concepts to describe the structure of a database, the operation for manipulating the structures, and certain constraints that database should obey. These three things important. See here data model, one of the set of concepts, describe the structure, obey the based on constraint, operation for manipulating the structures. Now, data model structure and constraints. How the data model structure will be designed or will be constructed. So you are going to construct to define the database structure, and that construct typically include elements, group of elements, and the relationship among the group of elements, such a group. And constraints specify some restrictions on valid data. This constraint must be enforced at all times. So what is the constraint? Constraint is it is a conditional. Okay, you are going to give some restriction on valid data, and these constraints must be enforced at all times. Next, how data model operation. Here, how database to retrieve and update by referring the construction of the data model. So, data model operations are used to specifying database retrievals and updates by referring to the construct of data model. Operations on the data model may include the basic model operation, that is generic insert, delete and update the data. User defined operation. So there is a two operations in the data model, basic model operation and user defined operations. The basic model operation insert, delete, update, and user defined operation compute, store, CPGA, update inventory. Now we are going to categorize the data models in the four components using the four components. The components is conceptual, physical, logical, conceptual, physical, implementation, self-describing data. The categories of data model. Conceptual is a high-level data models are symmetric data models. It provides the concept that are close to the way many users perceive data. நிறைய யூசர்ஸ் என்ன டேட்டா கேட்குறாங்களோ அந்த டேட்டாவை மட்டும்தான் ப்ரொவைட் பண்ணும். அதுதான் கான்செப்சுவல் டேட்டா மாடல் சொல்லுவோம். The physical data models, it is a low level or internal data models. Physical data models provide the concept that describe the detail how data is stored in the computer. These are specifically in an ad hoc manner through DBMS, design and administration. ஸோ ஃபிசிக்கல் டேட்டா மாடல்னா டேட்டா பேஸில் இருக்க டேட்டாஸ் எப்படி ஸ்டோராக இருக்குது, அதை எப்படி நம்ம இண்டெக்ஸ் பேஸில் அக்சஸ் பண்ண போகிறோம் அப்படிங்கிற விஷயத்தை டிஸ்கிரைப் பண்ணுறது தான் ஃபிசிக்கல் டேட்டா மாடல்ஸ். ஸோ இம்ப்ளிமெண்டேஷன், ஸோ இங்கே ரொம்ப முக்கியம். இந்த இம்ப்ளிமெண்டேஷன் இஸ் ஃபால் பிட்வீன் த above two, that is conceptual and physical. So there is a high level and low level. In between that data model, that implementation or representational data models. In between the conceptual and the physical, we say it is a representational data model. Why we are going to implement this data model? For main thing is commercial purpose. So here relational data models used in many commercial systems. Example. Now self-describing data models. So self-describing data model combine the description of data with the data values. ஸோ ஒரு டேட்டாவோட வேல்யூ டேட்டாவோட கம்பைன் பண்ணுறது தான் செல்ஃப் டிஸ்கிரிப்ஷன் டேட்டா மாடல் அப்படிங்கிறத நம்ம சொல்லுவோம். இதுக்கான எக்ஸாம்பிள் அப்படின்னு பார்த்தீங்கன்னா XML, key value stores and some NoSQL systems. Now we are going to discuss schema and instance. Schema. What is schema? So what is the use in the database? The schema is description of a database. Description of a database. What is the description? So in the database, we are going to describe structure, data types, and constraints on the database. So, and the schema construct. Schema diagram is the next slide. We are going to discuss component of the schema object within the schema, that is student or course. So here I am going to design one database with the name under the name student and the course. So here under the name of table student, we have give the name, student number, class major. Under the course name, course number, credit, hours, department. So this here I said the student course is a database schema. This is the example of the database schema. Now instance. So database state. Instance we also say it is database state. So the actual data stored in a database at a particular moment in time. This includes the collection of all data in the database. Its occurrence or snapshot is also called. The tape instance is also applied to an individual database component. Record instance, table instance, entity instance. So here I said database state is called database instance or database occurrence, database snapshot. What is it? You are going to store the actual data in a database at a particular moment in a time. That is the database state. And this includes the collection of all the data in the database. So I am going to see here is database schema. Now this is database state. Here data schema and database state is both is same, but both is having a relationship. So under the database schema, we are going to give a database state. So here course name, Introduction to the Computer Science, Data Structures, Discrete Mathematics, Database. So this is the database state. So database state, it refers the content of a database at a moment in a time. Initial database state refers the database state when it is initially loaded into the system. So what is the initial database state? என்னவா இருக்கும் அப்படின்னு பார்த்தீங்க அப்படின்னா என்ன ஃபர்ஸ்ட் நீங்க இந்த கோர்ஸ் நேம், கோர்ஸ் நம்பர், கிரெடிட்ஸ் அந்த இதை பற்றி நம்ம அந்த விஷயங்கள் இருக்கு இல்லைங்க, அதான் இன்ஷியல் டேட்டாபேஸ் ஸ்டேட்னு சொல்லுவோம். அதுக்குள்ளே இருக்கக்கூடிய கண்டென்ட்டை டிஸ்கிரைப் பண்ணுறது தான் டேட்டாபேஸ் ஸ்டேட்னு சொல்லப்போம். வேலிட் ஸ்டேட் அப்படிங்கிறது எதை சொல்லுவோம் அப்படின்னா ஸ்ட்ரக்சர் அண்ட் கன்ஸ்டன்ட்ஸ் இது ரெண்டையுமே சாட்டிஸ்ஃபை பண்ணால் மட்டும்தான் அது வேலிட் ஸ்டேட்னு சொல்லுவோம். A state that satisfy the structure and the constraints of the database. So next வந்து பாத்தீங்க அப்படின்னா டிஸ்ட்ரிக்ஷன். இது ரெண்டுக்குள்ள உள்ள வித்தியாசம் என்னன்னு பாத்தீங்க அப்படின்னா நம்ம என்ன சம் சேஞ்சஸ் நடக்குது, சாரிங்க. Distinction, the database schema changes very infrequently, but database state changes every time the database is updated. ஸோ ஒவ்வொரு தடவையும் டேட்டாபேஸ் அப்டேட் பண்ண நம்ம டேட்டாபேஸ் ஸ்டேட் சேஞ்ச் ஆகிட்டு இருக்கும். இப்போ டேட்டாபேஸ் ஸ்கீமா வந்து அவ்வளோ அதிகமாக தேவைப்படாது சேஞ்ச் பண்ண. எப்போ ரொம்ப இன்ஃப்ரீக்வெண்ட்டாக தான் நம்ம சேஞ்ச் பண்ணுவோம். ஸ்கீமா இஸ் ஆல்சோ கால்ட் இன்ஸ்டென்ஷன், ஸ்டேட் இஸ் ஆல்சோ கால்ட் எக்ஸ்டென்ஷன். So this is one. The student name, student number, class and major. The example, take in your class, in the classroom, everybody have name and have a register number, and what is your class? It is a second year class, and major is a triple E department. So these are both the things. The four members there is a doesn't change. Okay, up to the 4 years. But in the next year, the class will be changed. That is the third year. After the next year, a year after next year, it will be changed the fourth year. So the student name number now doesn't change and name doesn't change. So the class will be changed by year wise. Major also doesn't change in the 4 years. So there is infrequent change. We already discussed. So this is the database state. Here the course name, Introduction to Computer Science, Data Structure, Discrete Mathematics, Database, and we give the course number and credit our departments. So here the course name, course number, credit hours, departments will be the value of this will change if you have moved to the next year. The course name, everything change. Course number also change. Credit hours change. Departments change after 3 months. So every semester we change these values. That is, we said it is not a constant. We change at a particular moment of time. The values of the database will be changed. That values we say database state. Now we are going to discuss of the three schema architecture. We are going to discuss the database DBMS architecture. In this DBMS architecture, going to discuss before that what is the purpose to support DBMS characteristics. The DBMS sort of main characteristics is program data independence. The program and data is very independent. It will not be dependent. The program is not dependent on the data is not dependent on the program. Okay, if something change in the program, it will not affect the data. If something change in the data, it will not affect the program. That is will be the independence. So we say it is independent, and multiple view of the data also it's supported. So here the commercial DBMS product is not explicitly used and has been useful in explaining database system organization. So now we are going to see three schemas architecture in the DBMS. There is a three levels is very important: internal, conceptual, external. So internal schema, conceptual schema, and external schema. We already discussed the conceptual. This lies between the both the side, in between the internal and the external schema. So internal schema, we know internal schema is a physical storage structure and access path. Conceptual schema describe the structure and constraints for whole database for a community user. We also say it is a implementation data model. The conceptual schema lies between the internal schema and external schema. The external schemas are the external level to describe the various user views. Essentially use the same data model as the conceptual schema. So this is the diagram. Here we see the stored database. From the stored database, internal schema, that is access path, how to access the data in the database and how the data stored in the database described in the internal schema. The conceptual schema lies between the external level and the internal level. It is constraints and structure of the whole database. So based from here conceptual schema, we are going to view the data in the database. What are the data are stored in the database? How we are going to view? That is external view. So here mapping is very important in the three schema architecture and in the database. So mapping among the schema levels are needed to transform request and data. So programs refers to an external schema and are mapped by a DBMS to the internal schema for execution. The data extracted from the internal DBMS level is reformatted to match the user external view. So now data independence, logical data independence, physical data independence. So logical data independence, the capacity to change the conceptual schema without having to change the external schemas and the associate applications program. I said the program does need though there is no need to change. If the program change, there is no need to change the physical data storage in the data stored in the database. So physical data independence, the capacity to change the internal schema without having to change the conceptual schema. For example, internal schema may be changed when certain file structures are reorganized or new index are created to improve the database performance. So database data independence. When a schema at a lower level is changed, only the mapping between the schema and a higher level schema need to be changed in the DBMS. That's full support data independence. The higher level schema themselves are changed. Hence, the applications program need not to be changed since they refer to the external schema. Okay, thank you, students.